Okay, in this lecture we're going to talk about graphing linear functions. Now, a linear function, of course, is a straight line of some form, and our functional form for this is, in fact, f of x is equal to ax plus b, where a and b are real numbers. Now, our linear function then, in this form, as you can see, here's the form that we have it in for a linear function. Here a would be 3 on 2 and b would be 4. Now the simplest way to draw a linear function is to use the axes intercepts. Right, now the axes intercepts are the points where the line crosses the x-axis and the y-axis. Now the y-axis intercept occurs, right, if you look here, the y-axis intercept, here's our y-axis here, occurs when x is 0. And so I find f of 0, alright, which in this case you'll see is 3 on 2 by 0 plus 4, which of course 3 on 2 times 0 is 0, so I just get 4. So the ordered pair I have is 0, 4. And so that's this point here. Okay. Now the x-axis intercept occurs when, of course, y is equal to 0, and of course we know when y equals 0, that implies that the function value for some x is equal to 0. So we're looking here then when 0 is equal to 3 on 2 x plus 4, and we solve for x. So that implies that if I subtract 4 from both sides, 3 on 2x equals negative 4. And if I multiply through here by 2, I have 3x is equal to negative 8. And so x is equal to negative 8 thirds, which is 2 1/3, negative 2 1/3. So here that would be right here. Alright, so that's negative, actually it's 2 2/3, I should say. Alright, so negative 2 2/3, so we're about here. Okay. Now, we should have a checkpoint as well. In other words, let's choose an x value and see if it's going to work. Now, find the corresponding y value. So the best one to choose would be something that is even, so we can divide 2 in it. So let's suppose x is equal to 2. Then what I have is f of 2 is equal to 3 on 2 by 2 plus 4, so 2 goes, so I get 7. So the point I have is 2, 7. Alright, 2, 7 is here. There's our checkpoint. And so we can now draw our line. Like so. And there's a quick way to graph a linear function. Now let's look at this one here. This is a special case because notice that all the function values are 3, and it doesn't matter what x is. Even if I put x as 1 in there, I get 3. Even if I put x as 3 in there, I still get 3 because x doesn't play any part in it. So this is a special case, which is a horizontal line. Alright, so a horizontal line has the form f of x is equal to some constant, and that constant is going to be the y value that every point has, and so we have, here's our horizontal line. Alright, now what about the domains of these? Well, in this case you can see these go up forever, so all the x values are being used here and all the y values. So the domain of f here is all real numbers. And the range, of course, is the same, all real numbers. So for a non-vertical line, that's what we have all the time. Notice this one here for a horizontal line, all the x's are being used. So in this case here, the domain is again all the real numbers. But the range is one number only, and that is the 3. And so we use a curly type bracket here, or parentheses, to say that the set consists of only one element, which is 3. Okay, let's have a look at this one here now. We have x is equal to -2. So no matter what the function values are, we always have an x value of -2. So even if I had a function value of 0, I'd get -2. Alright, even if I had a function value of 6, I'd get -2, or -4, I'd get -2 as an x value. And so this is a special case, which is a horizontal line. Sorry, a vertical line. So this is a vertical line, and this always has the form of x equals some constant. Okay, and the constant value is the one that it goes through here. So notice it's going through -2. So any ordered pair, -2, 6, -2, 5, -2, 1, -2, 0, -2, -6, are all on this vertical line. You'll notice that this is not a function, because every ordered pair has the same x value. Alright, now what's the domain of this? Alright, well, the domain, of course, is the x values, and there's only one x value, and that's -2. And what's the range? Well, of course, every y value is being produced here, so in other words, we have -infinity to infinity. Alright, so that's a few here. This is a non-vertical line. Okay, and it will always have this domain and range. This horizontal line, okay, always has this kind of form. Okay, and it is a function. Okay, and another special case is the vertical line, which is not a function, but it always has this form here. And that's how we do the kinds of graphs that we're looking for. And of interest to us particularly is making sure we can identify which are horizontal lines and which are vertical lines, and also being able to graph accurately a non-vertical line.